Hello there, I'm Thomas Hatsios, a German-American pilot flying the Boeing 777-300ER international flight. We're going to be overflying Switzerland, Germany, then coming back to the Zurich International Airport, runway 1449, Lszh localizer landing. So now I'm in the cockpit for the pre-takeoff preparation of the PMDG simulation and Microsoft Flight Simulator X Boeing 777-300ERX. I'm going to start showing you the cockpit instruments and displays and the functions of the Boeing 777-300ERZ aircraft. I'm going to start with the primary flight display. The displays are the airspeed indicated, the airspeed selected from the autopilot, the flight director system panel, the ground speed, the radio altitude above the ground level, the magnetic heading and track, the barometric altitude above the sea level, and the target altitude selected from the autopilot and flight director system panel. We have also the artificial horizon with the altitude indicator and the pitch ladder decrease and the bank angle decrease. We have the Lszh localizer, the horizontal localizer and the vertical glide slope, and the Lszh localizer crossbars for manual guidance of the aircraft automatic guidance system to the destination airport and runway. So we have also the flight director for manual guidance of the aircraft and the autopilot crossbars for automatic guidance of the aircraft. We have also the angle of attack of the aircraft as it flies. We have the flight mode annunciator with the autopilot and the auto throttle later and vertical navigation modes and the wireless localizer frequency and name. So we have also the vertical rate of climb and descent of the aircraft in tens, hundreds and thousands feet per minute, or the steepness of the trigonometric angles in degrees you can climb or descend. I will show you also that. We have also the navigation display. The navigation display that displays all the GPS position, the inertial reference position of the aircraft. We have the terrain and weather reflections from the weather radar. You can see the red, green and yellow, the elevation of the terrain around you. We have the terrain map with the airports, the waypoint fixes, navigation fixes, and the voice stations, the NTPs and the ATFs. So these are the navigation guidance system you will find in every regular modern airliner aircraft. So I will show you what they do. We have also the magnetic north pole and true north pole magnetic variation depending where we are in the world. We have the next waypoint we're going to be overflying, the wind direction and speed, and we have also created a flight plan just right now, just so you that using the flight management computer. I input all the data of the aircraft for this flight. That includes the takeoff gross weight, that includes the empty weight plus the passenger plus the cargo, plus the fuel on board, that includes the trip fuel plus the reserve fuel plus the taxi fuel. So we're going to have the gross takeoff weight of the aircraft that is below the maximum gross weight. So we're going to use this runway right now for departure. We're going to have the calculations using the flight management computer. Is going to be done automatically of the mean aerodynamic chord position for takeoff. That is the mean aerodynamic chord of the forward wings in terms of percentages of the chord. Also we have the center. Πιο μετά γιατί έχει ζέστη τώρα. So we're gonna have also the center of gravity. The center of gravity in terms of the aerodynamic chord. Ναι, εντάξει. Όχι. Όχι.
Μου είπατε σήμερα θα μου δώσεις τα $550, το λέω.
Εντάξει.
Και εντάξει είπες και πλήρες και προφτήρες και τον περασμένο μήνα. Μην κάνεις κανένα αστείο σήμερα γιατί δεν συσσώνει τίποτα, το λέω.
Εντάξει. We're gonna have the aerodynamic chord position in terms of the center of gravity. We're gonna have the horizontal trim stabilizer position of the aircraft for takeoff. So we're gonna use the horizontal trim stabilizer in terms of the aerodynamic chord of the aircraft and the center of gravity of the aircraft. We're gonna have also other data calculated. So we're gonna have also, after all this, we're gonna have also We're gonna select the departure airport and runway. That we will select the seats that are instrument departures and waypoints uh, that include horizontal and vertical departure waypoints and fixes for the aircraft for the initial departure climb uh, to the cruise level, descent and approach and landing. We have the intermediate waypoints and fixes and the destination stars, the standard terminal arrival and waypoints and fixes that include horizontal and vertical waypoints and fixes for the arrival to the destination airport and runway. We're going to have the Lszh localizer frequency tuned automatically using the flight management computer, or we will input that manually using the radio management panel. So I'm going to show you also that. So we're going to have the complete flight plan or flight path for route of the aircraft from departure, waypoints, fixes, and horizontal, vertical, to the climb, to the cruise level, to the descent, and then approach and landing. We're going to have the Lszh localizer. So you're going to see the horizontal localizer and the vertical glide slope, the meters for approach and landing to the airport. So I'm going to show you all this data. You're going to see also the departure airport and runway. We're going to have the magnetic heading, magnetic north pole and true north pole, the magnetic variation again. So you're gonna see all this data here. You can see we start showing this. I hope you see it clear. We have the airspeed indicated, the airspeed selected, the barometric altitude. You can see everything in the primary flight display, all the data. I'm gonna show you then later when we're gonna make the flight. So I will show you after that the autopilot and flight director system panel. You will see the autopilot and gates and disengage switch, the autothrottle left and autothrottle right, and gates and disengage switch, the flight director and gates and disengage switch, the airspeed select no. We will select an airspeed nautical miles, knots, or Mach speed, and this will give a command to the engines of the aircraft, the General Electric 90 turbofan turbojet engines, and this is jet aircraft, jet propulsed aircraft. So we have the turbofan turbojet engine installed, one in the left wing, one in the right wing for symmetrical thrust and redundancy. They command the FADEX. The FADEX are the authorities electronic control computers, one installed per engine gearbox. So you will see how they function, the control and monitor all the functions and the sensors of the engines, like the engine start, the engine shut down, fuel flow to the engines. So I will show you right now what I mean. You can see the thrust levers. When I move the thrust levers forward or aft, I command the thrust lever position, and this will change the engine's thrust produced. So we have the parking brakes on, so the aircraft is not moving right now, as you can see. So we have here the N1, which is the low speed starter, and so the low pressure compressor and turbine of the turbofan turbojets engine. The maximum continuous thrust for takeoff 104.6%. So you can see the thrust position for the takeoff or for descent. So we're gonna have also the exhaust gas temperature. So the N1 is the low speed starter, and so the low pressure compressor and turbine of the turbofan turbojets engine. So you can see the red, green, and yellow limit. We have the N2, which is the low speed starter, and so the low pressure compressor and turbine of the turbofan turbojets engine. So is the high speed starter, and so the high pressure compressor and turbine of the turbofan turbojets engine. The N2, the fuel flow per inch per hour, thousands of kilograms or thousands of pounds. The oil pressure, oil temperature, oil quantity, and the vibration of the two states of the engine. So you will see also the flight management computer here, the one I use for the data input here. I have already created the flight plan, so you can see here. We have used the gross weight of the aircraft. This calculates the center of gravity, the flaps position for takeoff, and we have the V1, V rotated, and V2, the runway position, the slope, and the length, and the horizontal trim tail stabilizer. So we have the horizontal tail trim stabilizer here. So you can see the horizontal tail trim stabilizer here we use for climbing and for descent the aircraft as we fly. So you can make bang rolls in flight, bang rolls to the left and bang rolls to the right, also pitch up and pitch down the aircraft. So I will show you that later using the flight controls here. So we have the autopilot engage and disengage switch, the auto throttle left and auto throttle right engage and disengage switch, the airspeed select no buoy, select an airspeed, nav commands, not for max speed, these commands, the FIREX, the full authority electronic control computers of the engines, and this will give a command for N1 rotation limit speed, like for takeoff, climb, cruise, descent, approach, and landing. So we have the airspeed nodes Mach and also we have the flight level change, the climb continues, the auto throttle with the speed mode, and the LNAV and the VNAV, which are interconnected to the flight management computer. We have also the bang angle limit for cruising, the heading select node, the heading hold switch, the vertical rate of climb descent of the aircraft in tens, hundreds, and thousands of feet per minute, or the stiffness of the trigonometric angle in degrees you can fly the descent. And we have also the altitude select node, the altitude hold switch, the VOR localizer for the ILS localizer approach, and the approach switch for the auto land function of the Boeing 777-300ER. So you're gonna see also other functions here. We have the radio management panel. You have the parking brakes on and off here. We have the fuel flow control to the left and the right engine. We have the fire extinguishers. You pull out and switch this, and you use for fire extinguishing the engines. So we have also the auto throttle disconnect here. You switch, you disconnect the auto throttle and take the manual control of the aircraft like this. We have the takeoff go round and the thrust reverse. So we have also the horizontal trim stabilizer here. You can use this pitch trim for pitching up and pitching down the horizontal tail of the aircraft over here. So you can see the horizontal tail of the aircraft, and we can pitch up and pitch down the aircraft in flight using the terms of the center of gravity and the mean aerodynamic chord, which is over here is the maximum aerodynamic lift and the stall of the aircraft. You can see the thrust from the engines, the propulsion. So the systems here are 100% simulated because we have a professional simulator for this aircraft. So you can see here again we have the airspeed guidance of the aircraft, the heading guidance, the vertical rate of climb descent, the altitude guidance, the LNAV and the VNAV, the auto throttle on and off, the autopilot engage and disengage. So I'm gonna show you how to do that, also the flight director. So we have the main components of the aircraft we need to use for flying, also the primary flight display and the navigation display. Also you can use here, you can see the horizontal trim stabilizer position degrees. It's like 4 degrees right now, 4.25 degrees. You can see the green band is for takeoff. We have the parking brakes up and down. So the horizontal trim stabilizer also has the CMDR, the cutout switch. We have the pitch trim, the normal and the alternate. For pitching up and pitching down, the horizontal trim stabilizer. So you can use here the horizontal trim stabilizer to pitch up and pitch down the aircraft as you fly. So you can climb or descend the aircraft like this. So we're gonna use this aircraft from takeoff, climb, cruise, descent, approach, and landing. So I will show you how to use the flight controls right now in the thrust levers. using this side stick. Also the overhead panel, we have the electrical, the left and right engine, IDG, the great drive generator for the left and right engine, and the hydraulic system, the APU, the auxiliary power unit, and the batteries, the primary, the APU battery. We have the flight control computers and the ADIRU, the air data initial reference unit that controls the air data of the aircraft with GPS receivers, the airspeed and the altitude, and the inertial reference, the gyroscope, laser gyroscopes of the aircraft for the inertial reference position. So you can see here the overhead panel also. We have the electrical, as I told you, left and right engine, IDG, the backup generators, the batteries, the APU, gonna start the APU later, gonna see how to do that, the primary flight control computers, the ADIRU, the passenger oxygen, the rammer turbine, the hydraulic pumps, left and right engine driving, air pressurized also. You can see also the lighting system of the aircraft and the windshield wipers. The fire extinguishers for the engines and the APU, the electronic engine control for the engines and the auto start of the aircraft. I'm gonna make an engine start demonstration later. The fuel jettison, you can dump some fuel in flight to lose weight. We have the left and the right wing fuel tank, the center tank of the aircraft, you can see it's empty, and the crossfit valves and the fuel booster pump on and off switches. So you're gonna see also that later. The wing and engine anti-ice, the cabin pressurization system here, valves, also the bleeder, the pressurizer we need from the APU to start the engines, also bleeder from the left and the right engine for hydraulic fluid pressurization, cabin pressurization, wing and engine anti-ice, air conditioning and ventilation of the aircraft. So we're gonna use all these switches here on. You will see what happens. Then we're going to use the manual for the cabin pressurization. So you see the outflow valves here on position, the duct pressure, the outflow valves, and the total fuel on board, the flaps position, and the landing gear, whether it's up and down, the parking brakes, and the auto brake system. So I'm gonna show you how to use all the flaps here, also the speed brakes. So you'll see the flaps position, where they should be positioned right now. So I'm gonna show you the flight controls now. I'll go to the flight controls now. To the flight controls right now. I'm gonna show you the flight controls function, how to use them in flight. So I have this side stick here to control the yoke, the horizontal tail, the control column that controls the horizontal tail of the Boeing 777, and the irons and the spoilers are controlled by the control wheel. So this is the yoke system of the Boeing 777-300 jet aircraft. We have also the rudder pedals for the vertical tail, the rudder, the vertical tail stabilizer. So we have also the nozzle steering using the tiller. Also we have which is interconnected with the rudder pedals in the ground until some speed. Also the you're gonna see the thrust levers functions and the horizontal tail trim stabilizer that I have included with this side stick. So you're gonna see here we have this side stick, and you can see we can control like this. We can pitch up and pitch down the aircraft. When we're gonna fly, we're gonna see the flight in the end part of the video. So you can see we make turns to the right and to the left, so you can climb and you can descend. Also you can use the thrust levers. So using the thrust levers you can control the thrust levers like that, using this control stick and the side stick. So you can calculate how many degrees you want for takeoff, pitch up, takeoff, like 15 degrees, 10 or 15 degrees of pitch up. Also the bangles left and right. You have full deflections. You can see the side stick deflection is proportional to the yoke deflection. You can see both sides, the left and right, the first officer, the captain and the first officer are interconnected together. Also the rudder pedals, you can see the rudder. So you make turns using the rudder pedals like this. Also we have the horizontal trim stabilizer, the horizontal tail trim stabilizer over here that I showed you before. So we trim up and trim down, and you see how many degrees you trim up or trim down the tail of the aircraft over here. So I hope you like the deflections, and you can use both the thrust and the controls in flight to have coordinated flight. Also you can see also a little bit of the outside view using the flight controls, and then I will come inside for doing the rest of the systems explanation, the overhead panel, the engine start demonstration. Then we're gonna make a complete flight from takeoff, climb, cruise descent and approach using this aircraft. So you're gonna see that in the end part of the video. So you can see here we have the control again, climb, descent, make turns to the left and make turns to the right. So I hope you like the controls. I will show you now inside the rest of the system. So thank you very much for joining me. I'm Thomas Hatsios, the German American pilot flying the Boeing 777-300ER tonight flight. So I will continue now with the rest of the systems. So you will see me here, 38. So maybe 10 minutes more. We're gonna need to make the engine start. So we see all the systems. I show you the horizontal trim, the horizontal tail trim stabilizer. If you have a failure of the horizontal trim, you disconnect the CMDR from the normal to cut out. We have also the fuel control, the left and right engine, the fire extinguishers for the left and right engine, the weather radar, the rain radar, the transponder, the radio communication panel, the rudder, and now the aileron stream position you can see. But we don't use that often. We use the horizontal trim. So the horizontal trim tail is mostly important most of the time. So you need the horizontal tail. So you use the thrust levers here to disarm the speed brakes. So if you move the thrust levers forward, the speed brakes will retract. You can retract the speed brakes. Over here you see the speed brakes retract. Also the flaps are already retracted to the maximum deflection, 30 degrees. So you can retract them only when the thrust levers are idle. If the thrust levers are above idle, they retract. Also you cannot re-extend them like that. Also you can see we have some other controls, the auto throttle, the disconnect. You can see the position of the thrust levers here commanded of the upper and lower ACAS. Also we have the thrust reverse like this. So the thrust reverse, you can see how many percent you have opened the thrust reverse, and this will make the bypass flow from the left and right engine to deflect down the air forward and slow down the aircraft in the ground once you touch down. So you should not use that inside, only upon touchdown in the ground. So you retract the flaps like this. You will see the flaps position up. You extend like this. So we have here all the indications right now. We have also the radar screen. You can see the terrain elevation and the waypoints we have to follow. So we have here the display. You can see the airspeed indicated, the airspeed selected from the autopilot flight director system panel, the ground speed, the pitch altitude indicator, the magnetic heading and track here and here, magnetic north pole, true north pole, magnetic variation depending on where we are in the world. So now we have the normal, now we have the true, which is the geographic north pole, and it's 2 degrees offset here. So we change now again, we have magnetic again. So we have the pitch ladder in decrease here, the artificial horizon with the altitude indicator, like 2.5, 5, 7.5, 10 degrees, pitch up, 12.5, 15, 20, 17.5, 30. So you have pitch up and pitch down. We have the barometric pressure above the sea level, the barometric pressure of the outside atmosphere, the altitude selected from the autopilot flight director system panel, the takeoff ground modes are. You can see the waypoints here. We have the runway for takeoff. We have created already the flight plan. So you can see if we climb, you will see this needle moving up. If we descend, the needle moving down, the flight director and the Lszh localizer. So we can change a few values here. You can have meters, inches of mercury or hectopascals. So you have now also the display of the meters and hectopascals 1013 for here, setting up the barometric altitude, the elevation. So we have also here the autopilot flight director system panel, the auto throttle left off, the auto throttle right off. So you can select either auto throttle left or right off. So flight level change 179, flight director off. You disarm the flight director like this. You cannot rearm it. The modes set. The airspeed for takeoff. The LNAV and the VNAV, climb continuous, and the auto throttle. So we have a couple more modes, the airspeed change. We have the banger limit for the cruise level, heading select knob. Altitude select. The approach. So we'll use this for approach to the runway approach. So we have a couple modes now, and we have takeoff ground, flight director, flight level change speed, target altitude, target airspeed 253 knots. So you will see then we're gonna start flying. This will affect the aircraft if we use any of these. So you're gonna see also the autopilot engage and disengage like this. We have also the altitude here. You can see altitude and takeoff ground with the flight director. We can use the autopilot also. So now we have autopilot both left and right. You'll see the difference. The AP is on autopilot with the altitude, takeoff ground 253 knots, target altitude. So we'll use couple more flight level change instead of altitude. So we have flight level change now over here. So flight level change, autopilot on. We can use also heading hold with the flight level change. So we have heading hold, flight level change, autopilot on, and we have the vertical rate of climb descent of the aircraft, tens, hundreds and thousands of feet per minute. So you will see that also. Minus 3,500 feet per minute. It will give us a descent rate with the vertical speed. Another mode. So you will see minus 3,500 feet per minute here on. And you have to use the descent rate here. So we're gonna climb the other way, the slider. Plus 3,500 feet per minute. So you'll see the plus 3,500 feet per minute over here between the 2 and the 6. And the vertical speed again. So we're gonna use the descent again. Minus 3.5 degrees. So you see minus 3.5 degrees displayed here. Also we have the FPA mode, the flight path angle now. So in the flight path angle, the descent will look like this, and we're gonna have the descent rate over here displayed in the pitch altitude indicator of the Boeing 777-300ER. So it will give us a descent of minus 3. We have an aircraft here displayed. We can see it is coming in. You can see it displayed in this position with the diamond shape. You can see it moving. The radar screen is plus 2,100 feet. The arrow down means it's descending and it's coming closer in this arc between the 10 and the 5 nautical miles. So it will come full landing in this way for this runway. So you can see it keeps descending. Now it's plus 1,700, plus 1,600, and it's almost less than 5 nautical miles. We'll keep it closer, an eye closer. The radar is connected. You can see the terrain 2,800 feet. Maximum elevation, these mountains over here. Also the aircraft who is flying close to this mountain. You can see it's blinking. It's getting closer and closer. Have a couple more minutes, so you will see it's plus 1,100 feet. It's between the 5 and the 2 nautical miles. Plus 1,000 feet, plus 900. So you have the vertical speed here. Also I'm gonna show you the other way, plus 3.5 degrees. So this is gonna give us a climb rate now. So we have the aircraft coming in. Also we have another mode, a flight path angle, and the pitch altitude should be like that. As you can see, it's gonna be plus 3.5 degrees here between the 2.5 and the 5. So it will give us a climb to the target airspeed, target altitude. So we have the traffic here. This aircraft you can see with the yellow color. So we have it here. It's closer to us, plus 200 feet. It's coming full landing. It was plus 300 before, like 5 seconds. So it's getting down for landing. So we just spotted here in the radar. So now we go further away. So you can see the terrain is gone again. So we'll disarm the autopilot now. This disengages the autopilot. As you can see, we have the warning and the red color here, autopilot disconnected. We reset one more time just to see green light on, and we have also this switch here, disconnects the autopilot here. Press one time We have the warning again, autopilot disconnect with red color, and we press one more time and we confirm the autopilot disconnect to cancel the warning. So this is all we need right now. The overhead panel will go very quickly, and we have to go proceed for the takeoff after the overhead panel finish. So I will show you a couple of things here in the overhead panel, some systems. So you can see this is used for maintenance in the ground, disconnect fluid, hydraulic fluid, the circuit breakers also for maintenance, only reset in flight. So you will see here this view of the cockpit, flaps 35, 20 and 15. So you can see it's 15 here degrees, 15 degrees. So we need to proceed very quickly with the takeoff now. So we have the circuit breakers here. We need the APU to on, start. We have the thrust asymmetry compensator, the primary flight control computers, the left and the right IGG, the great drive generator, the backup generators, the left and the right, the batteries. So we have all the main components of the overhead panel: the electrical, the hydraulic, the window heat, the rammer turbine, the passenger oxygen, the cargo fire and APU fire, the electronic engine control for the engines and the auto start, the fuel jettison for the dumping fuel, and the left and the right wing fuel tank, center tank, wing and engine IDS, cabin pressurization, and the bleeder, the pressurizer from the left. And now the right engine. So we have the electric, the hydraulic. I will show you how we disconnect all the hydraulic pumps, what it happens. So we'll have in flight to use the rammer turbine. So you will see a fault here coming in, and if we look here, we will see all the systems failing. We have alternate flaps. You can see the stabilizer is lost, flight controls, hydraulic pressure systems, CR, CL and R, all three of them failing. So we need to reset the hydraulic fluid like this, back to the on. Hydraulic pumps are pressurized and electrical. We have the lighting of the aircraft and the windshield wipers. So you will see here cargo fire and APU fire, electronic engine control, auto start. I'm gonna show you the auto start of the engines after this. So we need to use that in the on. We have the normal and the alternate, electronic engine control for the engines. We can dump some fuel in flight, select the nozzle. We have this crossfeed valves, the fuel booster pumps. The center tanks are empty, wing and engine ADIs. The cabin pressurization. We need the outflow valves clamped and when using the manual. Also select landing altitude, and we have the bleeder, the pressurizer from the left and right engine, also from the APU. We need bleeder pressurizer here from the APU to start the engine. So you will see maybe we're gonna lose some systems. We have no bleeder for cabin pressurization right now, so we use them in the auto. So this is all main components of the overhead panel. Now we're gonna proceed with the CDU main components also. We need to start the engines in a couple of minutes. So CDU, we have the menu, the systems. Here you can see the engines, the display, the status. You can see the APUs running, the oxygen level. Over here the hydraulic, the checklist. We have the normal menu, what we need to do before start, the reset, the non-normal menu, the communications, navigation, synoptics, the doors are closed and the cabin can be pressurized, the gear, the temperature of the brakes and the pressure of the tires, the electric left engine, right engine, 120 to 200 volts, 400 Hz frequency, the IDC, the APU also, 120,000 kilovolts and the volts, 27 volts charge and discharge. So this is the electric page. the hydraulic left engine, right engine electrically pressurized. You can see where the hydraulic fluid goes. Also the shut-off valves and the air pressurized electric. So we have the fuel left and right wing and the center tank, how much fuel you have in the left and the right wing, and the total fuel on board. Center tank is empty with yellow crosses. Fuel booster pumps forward and aft on. Crossfit valve open. You can balance the fuel between the two tanks or feed either engine with either pump or either wing. We have the APU fed from the left wing using the DC motor. Total fuel on board 46.6. Its wing 23.3, low and high pressure fuel valves in the left and right engine, and the minimum fuel temperature here minus 37 degrees. In flight the fuel will freeze below this temperature. So we have the left and right pressurized air, the APU also, so you can see how much pressurized air you have from the engines or from the APU. If we use the engines forward, you use more pressurized air. So we need the backflow from the APU to start the engine starter in the ground. We have the flight controls here also. The last component, you can see when we extend the speed brakes, you can see all the flight controls here are moving normal. So both sides. So you can see all the wings, the rudder pedals, the horizontal trim stabilizer, everything is working out when you move the side stick. So we are in the last part now of the flight. So we're gonna make the engine start. Engine start now. And we have a few more minutes to go for flying. So you will see both engines. I'm gonna turn them off. We have the auto start already on. So both auto start on the overhead panel. Also we have the engine start auto start here. You can see engine auto start left and right, and engine shut down message here, and the engines both left and right engine shutting down. Also here there is no fuel flow now over here in this line. So engine shut down. You can see both the right and the left wing engine. Also here there is some spinning because there is pressurized air, so we need only to admit the fuel here. Fuel control on. So you will see the engine start very rapidly here. We have the fuel flow on and the engine start, both engines, right and left wing, and now we're going for our flight right now. We're ready to fly because we have already done with the flight plan. So we advance the thrust levers, take the clearance from the air traffic control here. So advance the thrust levers. We have the clearance for this runway. So we are open. We use also the tiller for nozzle steering, some brakes here, slow down, and we keep rolling here. The runway is open. Align with the center line. The LNAV is open to us, so you can see where we are, where we're going right now. So we have this view for takeoff, and we need to align with the runway again. So we use the full takeoff, go on power now, and we have like 19-20 more minutes for this flight. So we have V1, 100 knots, 130, V1, pitching up slightly, pitch up slightly. So this is the rotation for the climb, and we have the positive rate of climb. As you can see, we keep climbing. Landing gear is up, so you can see where we are right now. We are 1,400 feet above the ground, but 3,000 feet above the sea level, 220 knots, 215. We climb with 5,000 feet per minute. The pitch altitude like 70 degrees. All the modes right now armed, and you can see the terrain here, the elevation of the mountains in front of you, and also the runway and the flight plan we need to follow. Also the airspeed, we have the stall speed here and the flaps limit. So we keep climbing, and we have maybe like 2 more minutes for this flight. So we keep climbing. So we need maximum rate of climb right now. We have manual thrust, as you can see, maximum thrust here at sea. Also the autopilot. You see the maximum thrust and the airspeed we need to have also. We need to follow the first flight plan here, the waypoint. So we need to follow this waypoint here as we're climbing. So you can see the airport here behind you as we climb. So this is the beautiful view of the Boeing 777 300ER. So you see the Boeing 777, the views here. We have the beautiful view as we keep climbing, and we have also the Switzerland, the Germany, and the France here. So we have the star sign also. Beautiful star signs. So we need to show our bit inside now. Keep climbing, 17,000. So we have around 30 more minutes for this flight plan. Or 15 minutes. So we keep climbing. We have this beautiful star sign here. You can see the first waypoint, we just crossed it. We need to go for the second one. So we keep pitching up, 31,600. So you can pitch frame up the aircraft again. Beneath you can see the airspeed, the stall speed, the rate of climb, and the modes, the pitch attitude also the aircraft, and the bank angle of flight. So we are 33,000 feet here. We're gonna have the hand race now. Gonna have to adjust also the airspeed a little bit higher. So you can see the Germany in front of us. So we have the hand race and the cone race now. This beautiful view of the frozen vapors, and we need to start going back into the airport. So beautiful view, the galaxy, using the Boeing 777, this beautiful airliner. So we flying over the Switzerland, beautiful my homeland, the Germany, and the France. So we have the beautiful Switzerland and my home Germany. And we have this beautiful lake here, the Bayern Munich also. So we need to start going back. Like we need to start going back in like 10 minutes. So we're gonna retract also the flaps to increase the airspeed. So we're cruising 33,400 feet right now, and we're gonna have an airspeed of about 980 kilometers an hour. We have the Germany, the Bayern Munich here, and Switzerland. So we have this beautiful view of the Boeing 777-300ER, the most beautiful airliner of all time. It's a magnificent thing to fly with that as a pilot. Find this aircraft. So we're gonna cross again to the 3,000, and we're gonna have to follow the waypoints. To the 3,000. So now it's my own hands. We have manual control now. As you can see, using the side stick over here. So we're cruising to the 3,500 feet. You can see the engines also commanded flash. And now there is no autopilot on right now. It's the flight director. So we're gonna reach the cruise altitude now. 35,000. So here we are 35,000. 34,700 right now. Keep climbing a little bit more. And we're gonna have the cruise altitude. So we're shooting with 980 kilometers an hour or 300 meters per second, overflying Switzerland, Germany, and France with the most beautiful airliner of all time, the Boeing 787-300ER. So we have the frozen vapors over here, and this beautiful galactic, the most beautiful galactic view, I believe. So we need to start descending to the airport now. We can also connect the autopilot with race and the vertical speed, the altitude difference. So we're gonna make an altitude decrease in the vertical speed. And also decrease the airspeed component a little bit as we are approaching for landing. So now we choose with the autopilot on, connected, and we press through. Over here we need to descend even further. So we have some overspeed, we need to use our speed brake. So we come to this point. So keep descending. You can see also the engine thrust commanded right now is idle. We have to follow also this flight plan now, as you can see as we descending here. We're gonna slow down also as we descend. So here we are descending over Switzerland. And we have the airport, and maybe we need to also decrease the airspeed again. The limit landing gear may be down, slow down a little bit. And we have the wall localizers. So we need to slow down now as we descend. Use some flaps. You can select also the landing here, the flaps we need for landing. So we have the last part here, flight, the approach and landing part. So we have like 5 minutes more left. So disarm the autopilot now with manual control. We need to extend the descent approach path, the profile of descent, just to decrease the airspeed a little bit more. And it also make some speaker phone here. So we keep descending. We are in the approach profile right now. So we have the flaps extended. And we have the runway in front of us. So we're gonna have also the view for the approach and landing here as we approach the runway here. Gonna have a beautiful view, just like yesterday. So we're gonna have the view of the aircraft like this for the touchdown, as we're gonna touch down the runway, and also decrease the airspeed a little bit of the aircraft as we are descending. Increase the descent rate a little bit. And we are aligned, as you can see, with the runway. So we are 2500 right now. As you can see, we have the Lszh localizer here, the airspeed, the horizontal localizer, the glide slope. You can see the runway we are aligned, the rate of descent of the aircraft, the altitude, and the rate of altitude. We are 1400 right now. So we keep following the Lszh localizer. Very nice. And we have manual control of the aircraft, also the thrust. Has also manual thrust a little bit. You can need a little bit more airspeed. So we need to align also with the rudder pedals. Hold level, here level off. And we are for the approach now for a sweet, very sweet approach and landing. Τώρα φεύγω σε 2 λεπτά, περίμενε. Σε 2 λεπτά φεύγω. Ok, σε 2 λεπτά. So we align. 2 λεπτά περίμενε. 2 λεπτά περίμενε. Τελείωσε. So idle thrust. Here we are, just touched down very nicely. So parking brakes and reverse thrust. So we did a very nice landing. You can see the landing gear here in the nosewheel. There is no breakages of the tires of the metal parts, both the forward and the aft. So you can see the position of the aircraft starts after the touchdown. The counselor flag reverse, and we are ready.
Come on, let's go. Come on.